Do you mind pressing that for me? Okay, thank you.
There we go. Thank you. Okay, now we're good, Bobby.
Okay, good afternoon, everyone. My name is Bobby Taruk. For those also going to be watching on our YouTube channel and also on our Facebook group, my name again is Bobby Taruk. I'm the VP for Publicity, Social Media, and Marketing. With us today is Vikas Kerni. Actually, I've known Vikas through our Toastmasters Saturday morning workout club here in Naperville, just outside of Chicago in DuPage County. I love what Vikas is doing as well with our Toastmasters Club. Wanted to have him back again for our part two, mainly because he wasn't able to complete his presentation the first time, and also again answer the question about what should we be asking, what are those technical questions that as SMs or even project managers should be asking their team members. So the abstract is about project managers, agile project managers, and SMs managing software projects. I may not have managed, as an example, a software development project before. And I have not been, as an example, have not been a developer nor a QA tester in the past. More often, we may not be asking the right questions or Scrum or Agile project teams. Unless we have a mentor, we really do not know the right questions to ask. So in this session, Vikas will help us frame the different questions that SMs and Agile project manager should be asking their team. So in this part, Vikas will discuss what are the good Agile engineering practices and what are the specific metrics that project managers and Scrum Masters should be tracking to ensure good Agile engineering practices are followed. So about Vikas really quick, 20 years of experience overseeing complete life cycle of application development in a Microsoft environment, including design, coding, testing, and implementation. He has a track record of performance leading multiple projects through the full SDLC lifecycle, working hand in hand with a team of developers. He is a SME or subject matter expert on software engineering and software development standards, best practices, code constructs, architecture, and design. So he has also sophisticated programming knowledge, combining them with well-honed problem-solving strengths to direct the continuous refinement of advanced technology solutions to meet client needs. With that, Vikas, thank you again for spending time with us. I'll turn this over to you.
Thank you, Bobby, for that kind introduction. So, friends, today I will be giving a presentation, 7 questions you should be asking your technical team. As Bobby gave my introduction, I have been working as a Scrum Master also for my role, but I am more in technical role. And in Agile methodology, I have been using Agile methodology for 10 years, and I have seen it maturing. So I was just picking up I just went to a recently Scrum Master training. And there was a lot of questions whether Scrum Master should be technical or non-technical. I think that debate is settled. Scrum Master doesn't have to be technical. But in recent training, that very interesting topic came that Scrum Master should know the engineering terms, Agile engineering terms. And I pulled up what is the role of Scrum Master. We, as a Scrum Master, we have to give high-value products, and it should be agile, and the productivity of team should be high. So a lot of places what's happening is like we are implementing Scrum methodology, Agile methodology, which is great, but we have a software which is very old software, legacy software, and it's very hard to change. Things are very difficult to. These softwares have been built using waterfall methodology, and they have been using phase. To bring them Agile methodology brings a lot of challenges. So how we can use Agile engineering practices to make delivering easy. first question you need to ask your development team is, are you mature enough to use microservices architecture? What is this microservices architecture? To understand microservices architecture, we have to go back a little bit in the history. When we started building applications, we were using monolith architecture. What was monolith architecture? We would open a solution and enter all the code. If like most of the website would be in one code, we will use one database for all the database needs of the organization. I'm giving you an example of a pet shop commerce website. So you would have catalog, order, payment service, every code in one solution, and it will be using a database which would be central database. So what are problems with this architecture? The first problem is deployment. If you have to deploy, the deployment is very, very difficult. You have to use all the support staff. And if imagine if a company like Netflix, Amazon, Facebook, they have to upgrade their website. They have to bring all engineers on the support. And if something goes back, you have to roll back whole thing. There's too much cost, too many people involved. I remember one client where one company where I was working, we implemented an agile methodology, and one project was distributed to 4 teams. So 4 teams were working on same project. So there was a fight to get resources, testing resources, databases, who will be using the staging resources, who will be using QA, who will push the production. Since all 4 were working on the same code base, same project, same databases, and a lot of time was spent coordinating effort between multiple teams, which it's not pure agile, it's not enabling agile. So we can see there was a lot of problems with the monolith architecture, and then we moved to service-oriented architecture. In service-oriented architecture, we came up with services, and so catalog could be service, which could be used by multiple applications. If you have a credit card payment, you could use multiple websites could use these services. So this was better. You have better reusability here. And in service-oriented architecture, you would have one enterprise service bus. All the applications were either sending data or receiving data. And if enterprise service bus is down, whole application could come down. And during service-oriented architecture, BPM and business process modeling came very popular. And there was a thing, okay, you could come up with a requirement and you could create a service on the fly. So then we came to microservices. In microservices, you build small applications which can be deployed independently. Here we can see in this example, catalog API is a different application. Order is a different application. They have their own databases. The advantage of microservices architecture is that I can deploy catalog API independent of other applications. I don't have to bring all support people to deploy the application. So it reduces the deployment effort. If there were multiple teams were working, one team would be working on the catalog, another team would be working on order, and the third team would be working on the payment. So we can see, and that way you won't be fighting over source code, resources, and we can see how microservices architecture enables agile development. So that was microservices architecture. So the question 2 is, are we using the layered architecture and tiered architecture? This is very, very important question because all good engineering practices are based on this question. So let me tell you what is layered architecture. So when we build some website, we have a presentation layer. Presentation layer is what you are seeing. Like you have some payroll processing. You may see, okay, these are the list of employees. You may enter employees. So that is all presentation layer. It could be a website. It could be your mobile phone or your what you are seeing. And the business layer is about the business, how the payroll is being calculated. You are entering employees' data, and the business layer is processing. So this business layer is very, very important. And data layer is how you're storing the data in the database and getting it back. So the business layer is very, very important because the payroll changes will be less. Chances are it may change in 1 year or may not change. But the presentation layer, as we go in the history, has been changing a lot. We had only personal computer-based applications. Then we moved to the web. Now we have web, mobiles, and also tablets. So you can see the presentation logic is always changing. So it's a very good practice that you need to have this layered architecture where your presentation layer is different, business layer is different, and data layer is different. That way, if databases changes, your business layer is not affected. You can upgrade your database. You can go for some other instead of using this vendor database, you can go to other vendor databases, and only this layer is affected. And if you are changing business layer, only business layer is changing. So what is the tiered architecture? Actually, layered architecture enables the tiered architecture. You may be seeing a website, and behind the scene, there must be a lot of web servers, app servers, and databases behind the scene. So making sure that we have a good architecture, make sure that we can be deployed on multiple computers, and these computers can be added based on the user's need. And going back to monolith architecture, that's the advantage of going back to microservices architecture. This is also advantage of microservices architecture, especially on the cloud computing. The chances are on the catalog page, you would have a lot more people browsing that information where less people could be placing an order. So you have to make sure that catalog page can be scaled independently of payment. If everything was in one application, scaling would be too difficult. You would be wasting some of the resources. So that's the advantage of microservices architecture and also the layered architecture. The third question you need to ask is, what is the presentation layer architecture are you using? So chances are they're going to tell you some model view something. So model view controller is very popular pattern. So what is model? Think of an aircraft. In aircraft, you have different parts. So that is a model. View, the body, the aircraft body, that is the view you are seeing. And controller is the mechanism which is running the engine, running the propellers, running everything. So this architecture is this presentation architecture is very important so that it makes sure that the presentation layer code remains in the presentation layer and business layer code remains business layer, because it's very difficult to maintain this separation on the presentation layer. A lot of time we developers come with this questions is, oh, should I put this code in presentation layer or business layer? So this model view controller design pattern helps to solve this problem. So next question is, are you using some continuous integration or continuous deployment? So this is one of the agile engineering practice.
Because we've lost your video.
Sorry about that.
We have your video, so if you could just screen share again. I thought for a second there, I thought my Wi-Fi connection dropped. Ruben, I'm not sure if you need to allow Vikas again to do screen sharing.
It looked like he was freezing up, so I think he's going to try to re-log back in. So once he does that, I'll go ahead and give him a control.
Okay.
All right, here he is.
In the meantime, that is trying to reconnect, the State Farm Florence discussions for you as well, if you have experience in this one. So the State Farm do CI/CD, continuous integration, continuous deployment.
Yeah, we do. We do. It's a struggle because we have a lot of dependencies, and sometimes we have to go together, you know, and other teams have other priorities. So it's hard, but we try. And we also have my team especially, we just got into the whole microservices space.
Okay.
And we have 3 at this point, and we're looking at creating more to decouple, make certain components more efficient. So that's one thing we're I guess well into at this point.
Okay. So it looks like State Farm is actually doing this already. So because yes, we're ready for you.
All right, looks like it's coming back up now.
Hi, Bobby. You can hear me?
Yeah, we can. If you could just enable your camera as well, that'd be great. Thank you.
Okay, thank you. The next question is, are you using continuous integration or continuous deployment? So what was the problem with the old methodologies were, lot of time deployment phases were, we did development on time. A lot of time was during integration. Integration, when multiple teams brought their components together, things did not work the way they used to be working. And so things never worked the way it used to work. You used to spend a lot of time during integration. Generally, you missed the deadline, project shipment was delayed, and project kind of failed because they missed the deadline. They couldn't meet the deadline. So continuous integration is the process where you integrate every day, every time a developer check-in is his code, the continuous integration kicks in. What does it do is, whenever a developer check in his code, this continuous integration will build the application and then run some tests. I'll go into automated tests a little bit later. And based on the test, whether it failed or passed, an email will be sent to whole team. Okay, there was some bad code sent to this. Bad code was checked in the source control. As we know, source control is a place where developers keep their code. And if there's a bad code deployed, it can break the build. It can affect the productivity of other developers. I don't know, you have heard developers saying, oh my God, somebody checked in bad code and we are not able to build. So continuous integration makes sure that you are testing the code. The code is good. The worst fear, like as a developer, I have is like if I go to a company, I check in the code and I am not able to build the code. So using continuous deployment, you are able to make sure that code quality of the source safe is good. And this is one of the practice which is very easy to implement and you get a lot of returns. You can hire some outside help, outside resources. Developer don't need to be involved to set up the continuous integration. And it makes sure that the code is good, builds are good. In agile development, we have to produce something in 3 weeks. So chances are there are going to be multiple deployments in the staging in QA. It's a very good practice that we build a continuous or we automate the continuous integration and deployment process. So chances are either your lead may be running this, either your lead may have some development process, or you could have a DevOps. What is DevOps? DevOps is like the developer working with operation people. In old days, what we used to do is we used to build some code and we used to give to operation people, and operation people will tell operation people, don't ask any question, just deploy. And operation people will have a lot of complaints about the developers. So this DevOps is making sure that there's a good coordination, collaboration between developers and operations. So I have seen in DevOps, we are getting a lot of useful reports. What are the errors happening? They are monitoring our application. So a lot of good practicing matrices, I am saying, I'm going to tell you, you can get from ops. So either your development team or operations can give you this report matrices, which can tell you about the health of your application, how much is, are there some technical flags you should be worried about. So, okay, so before I move to other part, any questions on continuous integration, deployment? So Bobby, let you read the chat.
Yeah, because I'm not seeing any questions on the chat. We have a small group here, so feel free to chime in. Zach and someone with the letters BR, please ask some questions here. Right now is the right time to ask questions.
Hey, I have a question, Vikas. It's Ruben. So,
okay, Ruben.
Yeah, and so, we're in the age now, technology, where it's everything is cloud oriented, and we're working with third-party vendors more and more, and working with different systems and platforms. And so when you consider all those, how can you continually have anything that's a continuous, so to speak, deployment of any sort? Or is that a challenge in itself to try to coordinate all those things as we continue to move to these different, platform as a service, and everything is a service in itself, right?
Yes. So your question is like, we are working with third-party controls, third-party vendors, and definitely third-party, mostly they are doing in the cloud. And in the cloud, like they have a very good infrastructure. You can build pipes, deployment is pretty easy kind of thing. So they would have some continuous integration. Whereas like if like internal team is, when we have internal teams, and a lot of times people think, okay, we have to push something in production. So it depends upon your team, your environment. I have heard there are some companies where it's mandatory that people have to push some feature into production everywhere.
Gotcha.
So it can depend upon, it depends upon your company policy. It means the idea of Agile was that there's a difference between what you move in test and what you move in production. Everything you are deploying in test doesn't need to go into production. So those releases can be decoupled. So, but whereas like continuous integration is more about having good code quality, making sure that one developer doesn't check in bad code which affects other developers' productivity. The code is always good, compilable, they can build their code, and they're not bogged down some human mistakes, some manual mistakes.
Gotcha. Okay, thank you.
Sure. So I will be talking BDD. I'm very passionate about BDD. Thank you. I'll be talking about behavior-driven development. So the next question comes is, which is very close to me. And question 5, you need to ask your technical developers is, do you write tests for your code? This is this is one habit should be common. It's like, do you eat your vegetables? That way, all developers should write their tests. Let me give you a little bit testing ecosystem. What kind of tests are there? I'm sure you must be knowing all of this. So first thing is unit test. Unit test is developer writes a function and he tests it. That's called unit test. That developer should test every line of code. And once then component test. So I build a payroll package. I test the payroll package. And integration test, this payroll must be working with some other package, and that is called integration test. Every component should work properly in integration scenario. And finally, the system test, how the payroll system is working. And there are manual tests. So all other tests should be automated. And there are some tests which are not worth. They are called those are called manual tests. So test-driven development. Generally, as we know, if we add more code, your development time increases because you have to regression test. Regression test comes and your time increases. But if you are following test-driven development, you are making sure that all your testing is automated, and you can see that your time is reduced. If you are writing your automated test, regression test is very, very fast. It just takes a couple of, depending upon your test, it takes some time and you can push it very fast. If you don't have tests, as you add more code, it will take more time. You will fix one bug. Chances are 10 bugs would be created. You have to test whole application, and it takes more time. The interesting example I want to give you about SpaceX. SpaceX is like, I was reading a book about Elon Musk and SpaceX. It seems in SpaceX, before moving the rocket into the space, like 5 minutes before, they make code changes in the rocket software. And they have such great testing simulation system. They are able to test within a couple of minutes that this software would not mess up their rocket. And SpaceX also upgrades rocket software on the fly. And we have a website. The best time, like it took me a couple of hours to make changes and push to the production. So what is test-driven development? When developer writes a function, calculates salary, is taking some inputs, and is calculating salary, output is coming. So writing test is make sure that if you wrote some function for calculate salary, write some program also which takes the parameters and checks the output. That is all test-driven development. And don't you agree that all developers should write this code to verify that the code is working or not? So once the automated test-driven development is done, we have automated acceptance test. I remember like when we started working on Agile methodology in a company, And we started using a agile planning tool. I think it was Rally. And one day, big controversy happened. A flaw was found. The flaw was that we are not writing anything in acceptance criteria. Acceptance criteria is empty. So a big meeting was called and resolutions was taken. So people started entering acceptance tests, acceptance criteria. What they were entering, that program should work as per the requirement. And I was thinking, thank God they did not say I'm filling this line so that it doesn't complain. So for me, acceptance criteria is like if you have given requirement, okay, there's a salary, you are calculating salary, and you give expected value also. Okay, these are the values I'm expecting from the program. And there are tools like a QA person can take this tool and he can run a test to make sure, okay, the program is running or not. He can give, QA person can give multiple values and see the program is behaving or not. So a lot of time, what problem I see is like you must have seen in your environment, the business analyst, he gives some requirements to the developers code, QA will test, and then business analysts say, no, it's not working. This is not what I did. So he again gives new requirements to the developer, and developer will complain, the requirements were different, and they are different. So developer will again make changes, QA will again test, again there. So you have this cycle going on always. And you could miss the deadline. There could be a lot of problems in the team. So there's some technical way we can solve this problem. So here comes BDD. In BDD, the business analyst, in plain English, he defines a problem. Okay, here is the example. Like given my checking account balance is 3,000, my saving account is 5,000, and when I add $100 to my checking balance and move 1,000 to the saving account, my checking balance account is this one, 2,100, and saving account is 6,000. So here you are giving a requirement. If you are writing in the plain English, so developer, he can write his test for this requirement. So this is called scenario. So developer writes this test and verifies it runs. So this is called executable specification. I call it smart requirement. So here a business analyst is giving requirement which programmer can code. If the test passes, that means requirement was done or not. Like I was working for a client and the business analyst came and he said, because you have to make these changes to this application. And, from morning 5 to 7, it will call this particular third-party service. And you will get the value. Like some Saturday, Sunday, they give you fake value. Make sure you are getting the right value. And you need to finish in 3 hours. Then we will be pushing this code to the production. And this application process millions dollars of business. And I was telling that business analyst, by God's grace, even if I am able to develop this, how you can test? He said, don't worry, we will test it. I think he was telling if the client doesn't complain, it works. So if he was able to put, if he was forced to write something requirement like this, so we would be forced to think, okay, whether this requirement is executable, can it be coded or not? So once you ask your question, like developers, okay, are you writing your test? And if they say yes, so you can ask for the code coverage. Code coverage is a metric, like how much your automated tests are covering the code. So for business layer, data layer, it should be 100%. Whereas presentation layer, it should be 100%. But if they say we are using third-party controls, we are using complex UIs, we cannot test 100%. It's 50%, 60%. So based on the heavy conversation, heavy dialogue, and presentation layer is okay, not 100%. Whereas the business layer and data access layer should be 100%. So question 6 is, are you using any dependency injection? So I discussed the layered architecture. You need to have presentation layer, business layer, data access layer. You need to write automated tests for each layer. Business layer should be 100%. And it's very difficult to separate this presentation. It's very difficult to write tests for a particular layer. So what is this dependency injection? This dependency injection is a mechanism by which our business layer is tightly coupled to the presentation layer. So it's like a plugin. You can think of plugins. You take a presentation layer, you plug in your business layer, you plug in data access layer. So if your team is telling they are using dependency injection, it's very good news. Like it's a very technically very solid practice. So chances are, if you are using dependency injection, you would be using interface-based programming. What is interface programming? Interface programming, think of a satellite system, communication system. Communication system is so complex. You have your satellite talking to mobile phones. They are going through the routers. These devices are made by different companies, different vendors. Till you call somebody from USA to India, the call goes. How does that happen? Because all these equipments are being based on specification. As long as they meet the specification, that whole system works. That way, if like a presentation layer and business layer is separated by layers, it makes sure you can, today you may be using website, web layer, website, tomorrow you may move to mobile. If you're using dependency injection, you can decouple each component from each other and bring up new component. You can change the data access layer and without affecting the business layer or the presentation layer. So there's a matrix like what are the number of interfaces that you should be using, a number of interfaces you should be using against that file. So final question is, seventh question is technical debt. So here I think I would not give you some matrices. Here you need to have a discussion with your developers that what is the technical debt your team is facing. I'm sure you have heard this term before, technical debt. Technical debt is like you made some quick decisions. You use some old technologies and that is prohibiting. You use some third-party tools and now you are trying to add more functionality. Those old decisions is not letting you add more information. So how you get rid of technical debt is by refactoring. So how you get rid of technical debt is by refactoring. What is refactoring? Refactoring is you change the structure of your code without affecting the overall behavior of your tool. So now there are most of the tools, whatever the coding tool you are using, maybe for C#, they will be using Visual Studio. They are good refactoring practices where you can change name, move code around without breaking anything. And there are very good third-party tools, refactoring tools like ReSharper, where you can make sure that the internal structure of the code is better. It's easy to make changes to those code, and have a discussion with your team members. Like ask them what is the technical debt, and they may say, oh, long functions. When we write our code, that's a good idea is our function should be small. I have seen functions with 10,000 line of code, and those kind of functions are not easy to maintain. So having the psychometric complexity of function is, again, a lot of tools give you this parameter. It means your function is very, very complex if it is more than 5. And there are SonarQube reports, the third-party reports, which talks about, are you using good coding standards? So you can have a discussion with your technical team and come up with some parameters and make sure your continuous deployment is running and you are getting these matrices. So these were the technical questions we should ask. Any question? That concludes the presentation.
Zach? Anything
Yeah,
that,
can you go back one of your screens on technical debt? Because that's something that we're currently working and dealing with within our product team is how to handle technical debt as it comes in. So are there certain things that you can do as a team to try to kind of lower it or maybe eliminate the amount that you are getting?
Very, very, very good question. Personally, I think that you need some kind of technical debt. Everything is not going to be great, you know. So it's like, okay, companies we have some credit. We take some debit from the market and we keep it for operational purposes. But if there's some debit like which is prohibiting you, like I was working for a client, and so we used some third-party tools and performance was very, very bad. Application used to get application used to hang out sometimes. So what we did is like it was like when I took over the application and I had a discussion. So what I did is like I took small part of the application and I asked my business analyst like maybe one Scrum, let's rewrite this part of the application and see how the performance is there. And we wrote one part of the application like in that application like Zach, like if you click something, it used to take 1 minute to response to come back. And we rewrote that part like within 5 seconds, 10 seconds, you will get back the response. So once we showed this, our findings to the business users, and they were impressed, and they gave us three more scrums to fix other technical debt. So it's like if that technical debt, like people were complaining, and I mean this was no use to add more features when your people are not happy with your performance of your product. So that's something I'm very proud of myself, the refactoring, how we got rid of the technical debt.
Oh, nice. All right. Thank you.
And one thing is like one thing I like Zach, microservices architecture is that takes care of technical debt a lot, because you are writing small apps in microservices. So anytime you can rewrite the service, because service is small kind of thing, and you can rewrite anytime. Okay, it's Java, you can change to .NET. If you were in .NET, you were using some bad old technology, old framework, which is not scaling well, you can rewrite. I think the biggest benefit of microservices is microservices architecture is technical debt is reduced. You can imagine if your code is in one big application, it's difficult to change, right? But if there were small applications, you can handle one application at one time. It's like, how do you eat an elephant? pieces by pieces. And microservices architecture enables that.
Gotcha. Thank you. Thank you for that.
Because
Okay.
I have a higher level business question. So all of these best practices, I know you have stories on how you personally applied them. Is there any white papers? Are there any white papers that you can refer to on some of these best practices? As an example, they save X number of dollars, or their time to go to market using this best engineering practice shortened their go to market in 4 months, as an example. So, do you have any stories or documented white papers like that?
I have some technical documents which talks about continuous, and one from Microsoft where it talks about advantages of test-driven development. And I'll share with you. And if I find some more specific where it gave business values, definitely I'll share with you.
Okay, yeah, that'd be great. Other question I have is that are you going to be able to share this deck, and we can post it both on our LinkedIn page and on our Facebook group as well? Would you be able to share this? And it's okay if you cannot.
Sure, I'll no problem. I can share with you.
Okay.
So guys, if no further questions, so connect with me on. I have a software architecture channel, and connect with me on LinkedIn. So any question, feel free to ask. So thank you very much for your time. So have a good evening.
Zach or BR, last call. I do have Vikas' contact information, so if you cannot somehow cannot connect with him on LinkedIn, and if you need his email address, I'll certainly connect you with Vikas. Again, for those who will be watching this later on in our Facebook group or YouTube channel, you can claim half a PDU on technical and then half a PDU on strategic. And please do self-report your PDUs. If there aren't any more questions, then we will end the session today. Vikas, thank you again for sharing your time with us. Hope to see you Saturday.
Thank you, Bobby. Thank you for inviting me. Thank you very much.
Okay. Thank you, everyone. And Ruben, we can possibly end the recording here.
All right. Sounds good. We'll see you, Bobby.
Okay. Okay. Thank you. Bye-bye now.